Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So the problem statement is very simple. We need to do a diagonal traversal of the matrix. So if you can see in this example that if the matrix is something like 1 2 3 4 5 6 7 8 9, so what you need to do, you need to traverse the matrix in this manner and return the output. Okay, and it not necessarily it is a square matrix because it is an m cross n matrix and the ranges of m and n are in order of 1e4. So uh, and and also the product will also be in 1e4. So let's try to see the approach. I will try to generalize some method to solve these kinds of problem so that you do not face difficulty whenever you see some problems like this, or even some problems like spiral matrix. Many people face difficulty. So let's see the solution first. So you try to see. What you need to do is that you are given a matrix and you are asked to traverse it in certain order, right? So you see, the first order has to be upwards and then downwards and alternatively. So something like this. You need to traverse first like this. So I'll take a different color. You need to traverse first like this, and then you need to traverse like this. Then you need to go here and traverse, and in a similar manner you need to continue. Okay, but you see in the last iteration, either in this manner or this manner, you need to cross the last cell also. Okay, so I hope you understand it. And so what can be the possible approaches? What can be a possible approach to do this? I will try to generalize this so that you do not face a difficulty. Okay, so what will you do is that you keep one variable direction. Okay, you keep a boolean variable. This should be your boolean variable. Okay, so you keep bool direction. This direction you set it to 1 if you are traversing upwards, and you set it to 0 if you are traversing downwards. Okay, so you can see that every time you will just flip this direction vector, so this will act as a vector. I hope you can understand it. And also you keep an answer variable, right? An answer vector, this is a vector, and definitely it will store it has the total number of elements m cross n, right? M into n is the total number of elements because you need to fit everything in one vector. And what will happen is that you need to keep a variable I. So answer of I will store some matrix. So I'm going to store it in this way. Okay, so in general this kind of problem I'm telling that you store something in this manner. Answer of I equals to matrix. You are given the matrix row column. Okay, so you can see that if you store it in this manner, you are getting three extra variable I, R and C. So you go ahead and initialize some variables int I. Okay, you initialize it to 0. Initially it's pointing to the first element in the array. And you also store some variables row comma column. Since you are starting from the beginning, you need to have your both row and column initialized to 0. Okay, so I hope you easily understand it. And so what will you do in every step? You will just simply do it like this. And till when will you continue iterating? Okay, so you can do something like while your row, let's say I define the dimension as something like this. Let's say these are the m and this is the n. The rows are number of rows are m and number of columns is n. Okay, so what will happen, what can you do is that while this is less than m and column is less than n, it means that you are still able to traverse, you have not exceeded the bound. What you can do is that if direction is 1, it means that if we are traversing upwards, so what does it mean if we are traversing upwards? It means that my row is getting decremented. Okay, this is the row, this side is my row, right? And this side is my column. And so my row is getting decremented, r minus 1, and column is getting incremented. So you can do it like if the direction is 1, you initialize some variable. Okay, you initialize some new row variable and new column also, and you update those accordingly. Okay, so new row will get updated to something like r minus 1, and new column will get updated to something like column plus 1, else you update it differently. Okay, else you just update it differently. As you can understand that, as if you are moving downwards instead of upwards when the direction is 0, then what will you be doing is that you will be incrementing your row by +1 and decrementing your column by -1. So I hope you can visualize that and do that. Okay, and then after you are done, you got some new row and new column values, right? But they may be out of ranges, right? So if you are taking, I mean, if you are going upwards in some extreme case, you might be going out of the list. Okay, you might be going out of the matrix. So you just check if not out of matrix, not out of matrix. If you just check that if you do not go out of matrix, then what will you do is that you just initialize in your next iteration. You will just set, okay, so what will you do is that if in the beginning of your iteration you just set this thing, okay, as I told you in the beginning of your iteration you just set this thing. So at first you just write this answer of I is equal to nothing but matrix of RC and I plus plus. Then you need to ensure that at the beginning you are having a valid R and C. So if not out of matrix, if you are still within the matrix, you just set your R to be new R and you just set your column to be new column. Okay, I hope you understand this. And else you do something. Okay, you do something. What are those things which you need to do here? You need to definitely so after this you just end the loop. Okay, it will just go to the next iteration and it will just update your matrix, it will just update your answer. But if what will happen if it is out of the matrix, definitely when you are going somewhere out of the matrix, then definitely you need to change your direction. Okay, so definitely you need to convert to something like direction equals to not of direction. It means that I am just flipping the direction. Okay, this just says that I am flipping the direction. And also not this is not just sufficient. What you need to do is that you also need to update your row and column, right? So if you try to see, this is a matrix. Okay, and if you are going in an upward direction, if you are going in an upward direction and going out of the bounds, then your row, your new row has gone out of the bound, but your row and column are still here. So you need to update either your column to 1 or you need to update your row to 1. Okay, if you are going upwards, there are two cases of going upwards also. Case 1 is that you are going through this side upwards and you are going through this side. If you are going through the topmost side upwards, then you move update your column. And if you are moving upwards but you are I mean crossing through the breadth, then you just go downwards. So here you just update the column and here you just update the row. You just take here, so you can do something like if you see if your column is incrementable, increment the column. So it means that if column is less than n-1, you just increment the column, else you are incrementing the row, so you do something like this. This is when direction is 1. Okay, and you do a similar thing when direction is 0 also. Okay, so when direction is 0, it means that you are going downwards, so you can go through this as well as this. So if you are going through this, so you just say that if row is incrementable, increment the row. So you can just do like if direction is equal to 0, and if row is incrementable, that is if it is less than n-1, then increment the row, otherwise just increment the column. And that's all, that will be all. I hope you understand the approach at least, and definitely try it on your own. And if you can solve it using this pseudocode, I hope you have understood the solution already. You should be able to solve this using this pseudocode, and you just comment it in the video comment that you really understood and you are able to solve it on your own through this pseudocode. Okay, if not, you can still continue watching with the video. I will just solve it completely. So you see, I have got m rows and n columns. So I have a matrix dot size as m, which is the number of rows, and the columns is nothing but matrix of 0 dot size. So I hope you get it. And yeah, so I have some variables. What are those variables? I told, first of all, I will have a boolean variable direction. Okay, so I have a direction which is initially set to 1 because I am going upwards. So it shows that direction 1 means upwards. Okay, so The other way definitely means downwards. Okay, so I also have some integers I which will go through the answer variable. Okay, and also have row which is initialized to 0, and also have a column which is initialized to 0. Okay, and these I also have a vector answer definitely. Okay, and that answer is of size m cross n. I will keep filling values in this answer. Okay, I hope you easily understand this, and I will keep continuing while my row is less than m. Okay, while my row is less than m and my column is less than n. Okay, so I will keep in iterating like this. Okay, now what will happen is that at first what I need to do is that I just initialize my matrix. I will just initialize my answer value into the matrix. So initially I am having 0 comma 0, so I should put the first element of the matrix into the first element of the answer. So I will just simply do answer of I equal to matrix. I'm just putting the value and I will just increment I. Okay, so I hope you are easily understand this. Now what will happen, I will check for direction. If I'm moving upwards, okay, if I'm moving upwards, what are the things I need to do? I need to have a new row and new column variable, as I had told you. Okay, so new row, you are having a new row and new column variable. You will definitely update this, and new row is nothing but if you are going upwards. Okay, if you are going upwards, you are decrementing a row and incrementing your column. I hope you understand that. So row will be nothing but row minus 1, and new column will be nothing but column plus 1. Okay, so I hope that is clear to you. And else, if you are not going into that direction, what you must do is just the opposite. Okay, so you see, you perform just the opposite thing. You rather increment your row. If you are going downwards, you are incrementing your row and decrementing your column. Okay, so I hope you get it. You get it easily. Now these new row and new column might be out of bounds. Okay, but I check that if they are within bounds. So how can I check if they are within bounds? Row must be greater than or equals to 0, and row must be less than m. Am I right? Yeah, I am right. So row must be less than m, and also column value must be greater than equal to 0, and also again the column value must be less than n. So I will, from this I will know that I am within the bounds. That is I am doing in this part. If not out of matrix, I am still not out of matrix, and so I can easily initialize my next, for my next iteration. I will initialize this row and column to be new row and new column. I do not need any kind of updation to those. Okay, neither do I need to flip the direction, because right now I am going in the same direction. Okay, and else definitely one thing you need to do is that you definitely need to flip the direction, because now it's time to change the direction, because I'm about to cross the matrix. And also I will initialize my rows and column into the return path. Okay, so how to update that return path? Okay, so let's see. If I am having, if I'm going upwards, okay, if direction is 1, and otherwise its direction is 0 if I am going downwards. I have two cases. Within these two cases, as I told you, I have more two cases, right? So if I am going upwards, I could have crossed it in this manner or in this manner through the length or breadth. So if the column is incrementable, I will increment the column, and then if it is not, I will keep incrementing the row. So I want to say that if column is incrementable, so at first I can say that if column is less than n minus 1, I will increment the column, else I will simply increment the row. Okay, I hope you easily understand this. And here also something similar. As you are going downwards, I will say that at first I always want to increment the row. So if it is incrementable, I mean if it is not going out of bounds, that is if it is less than m minus 1, I increment the row, else I increment the column. Okay, so I hope this was clear to you, and I don't think this is much difficult. You should be able to come this on your own. And yeah, this is a general way to do, you can say also, right? You can keep three variables. You can keep an iterator I, a row and column. You just change your R and C, whether it is a spiral matrix question or whatever question. Okay, so these types of question you can do it in this way. Okay, so yeah, that's the thing. And what you need to return is return an answer. Am I missing anything? Let's run and check if it works. Uh, or we need to debug something. So you see we are getting a runtime error. This means definitely there is some error. So let's try to check our code. We have this matrix, we have this boolean variable direction. In this we are just flipping the direction. Okay, If we are not in the row, we are just flipping it, and you see whether so you have the I to be 0 initialized, column and rows both are 0. While R is less than M and column is less than N, you just initialize your matrix, you just initialize your answer to something like this. And new row and new column, you have two variables. If direction is 1, it means that if you are going upwards, you are decrementing your row and incrementing your column. Otherwise, you are doing the other way around. Now, you see if you are within the bounds. Okay, so if you see this, I'm talking of the new row and new column, right? If my new row and new column is within the bounds, that is what I want to check, because this is R and C are still the old ones. Okay, so if they are also within the bounds after taking a step, then you can do something like initialize them. Okay, and otherwise what you can do easily is that uh, you just flip the direction, and but before that you check if the direction, if I was going upwards, and if column is incrementable, I just increment the column, otherwise the row. And for the other way around, if you are going downwards, my preferable thing is to increment the row. So I hope this should work. Let's see. So you see we get the accepted thing. If we try to submit it and check if it works, or do we still have some error? So you see, we get the accepted thing, and also our method is really clean since we get 100% bits, and also it does not use any that much of extra space. Definitely for this returning answer you need a vector, but otherwise I'm just using simple sum of those some integer variables and some boolean variables. I'm not using some extra space, and also I am simulating in a very really clean way. Okay, so yeah, that's all I guess for this problem. I hope you understood this approach. So yeah, that will be all for this video. I will meet you in the next video. Till then, thanks a lot.